Let us now talk about the types of reactions we have at this level of chemistry. The reactions in general chemistry can be broadly divided into 4 types. So 4 types of reactions. There are the so-called combination reactions. These reactions are also called synthesis reactions. There are the ones that are called decomposition reactions. There are those that are called single displacement reactions. And there are those that are called double displacement reactions. Let us take a look at each of them. Let us begin with combination reactions, also called synthesis reactions. If you have a small substance A and you react it with another small substance B, and both of them combine together to give you a bigger substance AB. This is what is called a combination reaction. This is small, this is small, and this is big. Let us take a look at an example of combination reaction. Anytime you see 2 substances combined, for example, if you react sodium, which is a solid, with chlorine gas, and you get sodium chloride. Now let us balance the equation. If you place a 2 here and you place a 2 here, the equation is balanced. Now we have a combination reaction. Let us now take a look at the second type of reaction, decomposition reactions. Decomposition reactions are the opposite of combination reactions. If you have a larger molecule AB and you break it apart into smaller pieces, this is called decomposition reaction. An example: if you want to generate oxygen in the lab and you take some potassium chlorate and you heat the potassium chlorate, you will get potassium chloride and oxygen gas. Let us balance the equation. There will be a 3 here, there will be a 2 here, and there will be a 2 here, and the equation is balanced. This is a decomposition reaction because we started with something that is bigger and we ended with some things that are smaller. Let us now take a look at single displacement reactions. If you have a substance A and it is alone by itself, and you react it with a substance BC, and A decides to kick B out and take possession of C. Now B is alone by itself. Or you can use this analogy. A is dancing alone, but B and C are dancing together, and A decides to dance with C, kicking B out. That is a single displacement reaction because A is displacing B. An example of this is if you drop zinc metal into hydrochloric acid. Zinc chloride salts will be formed and hydrogen gas will be bubbled out. This is an example of single displacement reaction. Let us balance the equation. Because zinc is kicking out hydrogen and taking possession of chlorine. Let us now take a look at double displacement reactions. If you have a substance AB and you have another substance CD, or think of it in terms of dancing, A and B are dancing together at a party. C and D are dancing together at a party. And then they switch partners so that A now dances with D and C now dances with B. Now, take a look at the way I have written the products. I wrote A first and I wrote C first. Why did I do that? The reason is because anytime we want to write an ionic compound, we usually write the metal followed by the non-metal. And that is what I'm trying to imply here. So the metal first, followed by the non-metal. Let us now take a look at an example of double displacement reactions. If you have lead 2 nitrate, which is a soluble compound in water, that is why the aqueous is being added, and you react that with potassium iodide, which is also a soluble substance in water. Both of them will exchange their partners, and you will end up with lead 2 iodide, which is actually not soluble in water, and potassium nitrate, which is also very soluble in water. This is the first question you probably are thinking about. How do I know what is soluble and what is not? We will learn about precipitation reactions later. Let us now balance this equation. If you place 2 as the coefficient of potassium nitrate here, so that the 2 nitrates can be balanced, by placing a 2 here, you now have 2 potassium. So we need to place a 2 here. And by placing a 2 in front of potassium iodide, we now have 2 iodine. And we have 2 iodine, we have 1 lead, we have 1 lead. So this is now a balanced equation.